Okay, welcome to another lesson. In this lesson, we are going to look at problems involving the law of flotation, which is a special case of Archimedes' principle. And we'll do this by looking at example 5 in your course book. And let's go straight to the question. In the question, we are told that a boat of mass 1,000 kilograms floats on fresh water. If the boat enters seawater, determine the load that must be added so that it displaces the same volume of water as before. And of course, you can take the density of fresh water to be 1,000 kilograms per meters cubed and that of seawater to be 1,030 kilograms per meters cubed. So I'd like you to pause the video, work out the solution, and then after you have worked out the solution, check the solution and then proceed with the video so that you can see how we solve this question. So go right ahead and pause the video and do exactly that. Okay, welcome back. The solution to the question are as shown below. Again, you can pause the video and study the solution, and then after that, continue with the video and see how we work out the solution. Okay, let's go right ahead and now get the solution to the question. You'll be able to see how I get the answers to the various parts of this particular question. Now, I want to start by reminding us of the law of flotation. The law of flotation states that if an object floats in a fluid, the weight of the fluid displaced will be equal to its weight in air. Remember, the weight of the fluid displaced is equal to the upthrust. And because it is floating, the fluid is the one which is supporting it. And therefore, if we know the weight of the object in air, first of all, we know that the upthrust on an object is equal to the weight of the fluid displaced. Now here is a situation whereby the object is floating in water. So let us understand this situation. We know that from the law of flotation, if an object is floating in a fluid, the upthrust on the object due to the fluid is exactly equal to the weight of the object in air. So in this case, the boat has a mass of 1,000 kilograms. We can work out its weight in air. By doing that, since it's going to float in fresh water, we will automatically know the value of the upthrust it will experience in fresh water. It will also float in seawater. We will also know that the seawater provides an upthrust on it equal to its weight in air. So let's go step by step. So over here we have the mass of the object. We can work out its weight by doing weight is equals to mass times gravitational field strength. The mass is 1,000 kilograms. The value of the gravitational field strength of the Earth is 10 Newton per kilogram. Over here, the kilograms and the kilograms will cancel out, and that will give us 10,000 newtons. 10,000 newtons. This is the weight of the boat in air. According to the law of flotation, since this boat floats on fresh water, the upthrust on the boat due to the fresh water must be equal to 10,000. So, upthrust is equal to 10,000 newtons. But from Archimedes' principle, we know that upthrust is equal to weight of the fluid which is displaced. So this one is going to be equal to the mass of the fresh water displaced times the gravitational field strength, which is equal to the mass of the fresh water displaced is equal to the density of the fresh water times the volume of the fresh water displaced, of course, times the G. The density of fresh water is 1,000. The volume is V, and the G is 10. And of course, we can see that over here, the volume will be equal to 1 meter cubed. Will be 1 meter cubed. This is the volume of the fresh water displaced. Now the boat now enters seawater. Seawater has a higher density of 1030 kilograms per meters cubed. Now if it enters seawater just the way it is, it's going to sink less. In other words, it's going to displace less volume of seawater. And why is that? It does that because the density of seawater is higher than the density of fresh water. But here is a situation where we want it to displace the same volume of salt water or seawater as fresh water. So we know that since it's going to float in seawater, let's calculate the upthrust, which will be equal to density of seawater, volume of seawater displaced, times the value of the gravitational field strength. The density of seawater is 1030 kilograms per meters cubed. The volume, we want the volume of the seawater displaced to be 1 meter cubed. And the value of G, of course, is 10 Newton per kilogram. Of course, over here, I ought to have put kilograms per meters cubed so that the units are going to cancel out and I will be left with newtons, and that will be 10,300 newtons. This will be the upthrust in seawater. Let me say this one is seawater or salt water. This is the upthrust in fresh water. You can see that the upthrust in seawater, which is salt water, is higher than the upthrust in fresh water. We realize that we must have added a load, an extra load of 300 newtons on the boat. So the extra load that we must add on the boat is equal to the upthrust in seawater, which is 10,300 newtons, minus the upthrust in fresh water, which is 10,000, and we get 300 newtons. And the problem is just as simple as that. All you need to realize here is that in seawater, the density is higher, and therefore, if no load is added on the boat, the volume of the seawater that will be displaced will be less. But we've been given a condition in this question. We've been told the volume of the seawater displaced must be equal to the volume of the fresh water that was displaced. So how much extra load must be added onto the boat so that that condition is fulfilled? The extra load must be 300 newtons. So I hope I've been able to shed some light on how this question is done. You can work out the others or look at my other videos of how I solve the other examples. But each time you look at my videos, I'll be giving you a chance to solve the question first. So always pause the video, do it yourself, and then continue with the video to see how I will have done it. This way, you will save a lot of time. If you find that the way you have done it is exactly the way I've done it, you could go through the video just to confirm, because there could be other things that I would say in the video that may be of benefit to you. Or if you're in a hurry, you will just be contented with the way I've worked it out and then proceed with other questions. So let's stop this video at this point, and I hope to see you in my next lesson. If you like the way I'm explaining these video lectures, please subscribe so that you can continue to benefit. You can also invite your friends to subscribe to this channel.